with the first 3 pages of the study guide, as I said, and this should be mostly review over significant figures and conversions, hopefully just enough to remind you about what to do in certain cases. Please know that I hate to say it like this, but this is pretty boring for me. I hope it's not boring for you. It's boring for me only because you're not here and I don't have any students to talk to. But again, hopefully this is the quickest way to get you through some of the review topics. All right? Okay, significant figures. Used in the lab. This is something that I'll stress every time we do a lab that requires some type of a measurement. You want to make sure that you read your measuring device to the proper number of significant figures. And believe it or not, one of the most common mistakes made is with our electronic balances. Now you know all of our electronic balances go to the thousands place. So you have 3 places to the right of the decimal. And you know what, I've already made a mistake here because I don't have a unit. It's of course going to be in grams if I'm using our electronic balance. The mistake that students make is, let's say that I have a 2 in the tens place. If these are zeros, many times students won't fill those in. So just a heads up, if it's 0.2 grams, make sure that you use all your sig figs there and fill in the spaces to 0.200 grams. You'll probably have a placeholder here as a 0 also. With significant figures is defined as all of the values that are known plus an estimate. So what you know for sure plus one estimated value. So here I have 2 rulers, and again, a mistake. We don't have units on our rulers. Now, we rarely would use the customary units, so I am absolutely certain that these are both centimeter rulers here. You want to use your marked lines as your known value and one estimated value. So let's just read our measuring devices to the correct number of sig figs. For this one, if you were to draw a line straight down, what number do you know for sure? Well, the 11, that's right. And your estimated value is going to be, and this is where you can be plus or minus 1 or 2. I would probably say it's 11.0. Again, our units are centimeters, so there's my unit there. I know the 11 are certain values. That is marked on my ruler. Now the estimated value is the 0 there. So the numbers you know for sure plus 1 extra value there. For this, and this one might be a little bit easier to see as far as the sig figs go. What number do you know for sure? The 8, that's correct. All right, and then there's your decimal. Now the estimated value, and again, this is where you can be plus or minus 1 or 2. I would say it's probably about a 4. All right, it's not quite half, so 8.4, and again, the unit there is centimeters. All right, in this one, my calibration is a little bit better here. We have, instead of just going every centimeter as we did in the first one, we have the centimeters that are divided into tenths. So for the first one here, oops, not quite a straight line there. You'd be a little more careful than I was here to see where it comes across. The value now that we know for certain is more significant. This is 31, and then 1, 2, 3, 4, 5, 6. 31.6 is what we know for certain. And then the estimated value comes from about where the head of the arrow ends up in between 0.6 and 0.7. I have it as about 0.8. But again, if your paper is a little bit different, if you have 31.66 or 31.7 or 67, something like that, you're going to be okay, because your estimated digit can be plus or minus. And then we have one more here, like I would try to draw a line straight up here. I have this as 31.1 is certain, because it absolutely goes to the 31 mark there. And again, this is where you can be a little bit off. I wanted it to be 31.10, and my units there in centimeter. But your estimated value is just that. It's an estimate, so you can be plus or minus. One more here. We have, what do you think this could be coming from? Yeah, this is a graduated cylinder. What units would probably be used in a graduated cylinder? Yeah, milliliters. All right, so there's my unit. Notice it goes up the more there is. And then there's this, oh, what is that called? When you have those adhesive forces, attractive forces of the water, it forms a meniscus, right? Meniscus. Which part do you read for the meniscus? Yeah, along the bottom. All right, so you want to read right along the bottom. Be careful, burettes can read differently than a graduated cylinder. There's 6 milliliters, 7 milliliters, 7.2 that we know for sure, or for certain, as these are marked into tenths. So 7.2, there is our exact numbers, and the estimated value I have down as about a 7. Again, the estimated value there can be a little bit plus or minus 1 or 2, and this is going to be in milliliters.